In this video, we'll learn how to use Excel for standard normal distribution and normal distribution. There are a couple of functions in this videos. The first function is the norm distribution or norm dist. This function will return the normal distribution or the area under the curve for the specified mean and the standard deviation. This function takes in four inputs: x, mean, standard deviation, and cumulative. For the x, this is the value we want the distribution. Mean, the second argument, this is the arithmetic mean of the distribution. And then next is the standard deviation of the distribution. And then for cumulative, we have two options. True, if we want the function to return the cumulative distribution function, and false if we want the function to return the probability mass function only. For the standard normal distribution, we will use the mean of 0 and the standard deviation of 1. Remember, the standard normal distribution is just the normal distribution, but the mean is 0 and the standard deviation is 1. Or you can use the function norm.s.dist. If we have an extra letter s here, we will know that the mean is 0 and the standard deviation is 1, and there's no need to enter the mean and the standard deviation because that is already a false value if we use the norm.s.dist function. Okay, so this one will return the area under the curve. What happens if I know the area under the curve, but I want the value on the z-axis, right? And that would be the other way around. So we use the function, another function, norm inv, inverse norm. Inv stands for the inverse, right? So norm inv. This one will return the inverse of the normal cumulative distribution for the specified mean and the standard deviation. This function has three inputs. The first input is the probability, the second input is the mean, and the last one is the standard deviation. Probability, this is the tricky. Make sure that we look for the area to the left of the value that we are looking at, okay? The area to the left. Mean is just a regular arithmetic mean, and then the standard deviation is just the standard deviation of the distribution. If we are using the standard normal distribution, we can also use another similar function with the extra s.s before the inv. If we include the s, then it represents the standard normal distribution, and there's no need for you to enter the mean and the standard deviation because the Excel knows that the mean should be 0 and the standard deviation should be 1. Okay, so in summary, we have the standard normal and the normal distribution. To find the area to the left, we just use the norm.s.dist if we are looking at the standard normal. If we are using the different mean and the standard deviation comparing to the standard normal case, then we use the norm.dist without the s, and then we input the x, right? The x and the mean, the standard deviation, and we put in the true argument, the last argument. That means I'm looking for the left area. I'm looking for the cumulative value. And then to find the area to the right, we just take 1 minus the area to the left, right? Remember, 1 is the entire area under the normal curve. If we take that 1, we minus the area to the left, then we get the area to the right. Because Excel doesn't have a function that finds the right area. It only gives you the left area, and then you can apply the other properties to find the area to the right. And then for the area in the middle, we take the upper value minus the lower value. And lastly, the value on axis, we use the area to the left for the inverse functions, and it will give you that value on the axis. If we do not use the dot S, make sure you include the mean and the standard deviation. If we use S, then Excel knows that the mean is 0, the standard deviation is 1. Okay, looking at this example, we want to find the area between minus 2.04 and 1.99. So this is the normal curve, right? This is the Z. Z, the standard normal distribution. This is the Z. So you know that if we use Z, then it is the standard normal distribution. Therefore, the mean should be 0 and 0 here, and the standard deviation should be 1. So now I'm looking for the area between this negative value, negative 2.04, so a little bit to the left of negative 2. And then 1.99 is a value to the left of number 2. So I label this is Z1, this is Z2. So what I do is I use the norm.s.dist, the standard normal distribution, right? The standard normal distribution. And then I input the Z2. The Z2. That means I take the upper value and I put the 2 for the argument, the second argument. The reason I put 2 because I want all the area on the left. Remember, the normal distribution function only returns the value on the left side. So if I use the looking at the first expression, norm.s.dist, this is the standard normal distribution at the point Z2, 1.99. So that will give me the area on the left side, like this one. Okay? And you know that this is not true because we don't want the area down here, right? Even though that it gives you the area on the left side of Z2, but then it includes the extra area over here. We don't want that. That's why I need to subtract. I need to subtract, and then I use another function, standard normal distribution function, to find the area on the left side of negative 2.04. So the second function here, it gives me this small area on the left side of Z1, which is negative 2.04. So the entire area below Z2 minus the left area of Z1 will give me the blue region, the one in the middle. And that is how we find the area between two Z value. Okay, so equal norm.s.dist open parenthesis 1.99, which is the upper number, comma, true. If I use S, I do not need to specify the mean and the standard deviation. And then minus the small area on the left of negative 2.04 to get me the area in the middle. Okay, another example, we are looking to find a z-score. This time, we are looking for the z-score, and we are given the area to the right of that z-score, and that area is 0.4567. Okay, so imagine that we have some area 0.4567, and we don't know this value right here, z equal a question mark, right? We don't know this value. So we are looking for this value that has this particular right area 0.4567. Remember that the normal distribution function or the inverse function is only text in the left area. So in this case, we have to use the inverse function, inverse norm. So norm.s.inv. The reason that I .s, I use the s version because this is the z value. So we know this is a standard normal distribution. We don't need to specify the mean, and we don't need to specify the standard deviation if we use the version with the s. So use the inverse function. Remember, when you use the inverse function, you need to input the area on the left of the value that you are looking at. The area on the right, we know that value, but we don't know the area on the left. Remember, the entire area should be 1. So to find the area on the left, we take 1. We subtract the right area, so we can get the left area. And that is the area that we want to place on Excel. So norm.s.inv, inverse norm of the area on the left side, which is 1 minus 0.4567, and it will give you the z value, right? It will give you the z value. So we can try it quickly here. Equal norm.s.inv, and 1 minus 0.4567, and that will give me 0.108751, and that should be the z-score for this given area to the right of that particular z-score.